Alright guys, so in this week we are just going to finish off our game and we're going to refactor a little bit of our code to make it a little bit nicer to read and so that it follows some standards outlined by Unity. Now, the first thing that we're going to do here, I think, is we're going to do a little bit of code refactoring because up until this point, we've just kind of getting things working. I think it's important for us to understand some of the importances and some of the conventions associated with scripting here. So I'm going to open up my scripts folder here, and you can see I have a number of different scripts that I have created in the past, and I'm going to go through all of these to make sure they adhere to some of the standards that we have here. And so I'm going to click on the boundary script to start that guy off. And we're just going to have a quick little look here to see if everything is good. This one is a very simple script, so this one is actually pretty good, so I'm kind of happy with this. You see here on the right side, if I can just access my other scripts here, you can see I have my destroy by contact. Okay, my destroy by contact is also pretty good. We will be revisiting this shortly. We have our destroyer script. This destroyer script is also good. Okay, destroy by contact and destroy by destroyer. Okay, we also have our mover script where this one here is somewhere we can actually do a little bit of an improvement. Okay, the one big improvement that I'm looking for really across all of these scripts is this one right here. Okay, now in our case here, this is actually fine. Okay, and now that I look at this, this is part of what is the start function. Remember, our start function is called only once. Okay, and so in fact, this code right here is actually pretty good. If I go to my player controller, on the other hand, here there is a number of things that I don't like about the fact that we use the word get component here in my update loop. Now, the process by which Unity goes out and finds the component that we are requesting, that process takes time, okay? And so by calling this get component function every single time we are updating our game, it's actually like a poor programming practice because that process takes a lot of time. And in fact, we can get away from doing that by doing a nice little trick here, which is basically caching a reference to a component. When I say caching a reference to my component, I'm basically saying that I want to get a reference to my rigid body component once, right at the beginning of my game, and use that reference over and over and over again instead of calling get component every single time. And so the best practice here to do is if you know that you're going to be getting a component repeatedly over and over and over again, for instance, in our update loop, then we can do it a different way. And the way we're going to do it here is by going all the way up to the top here, and just above my first private variable, I'm going to declare another private variable. And this private variable is going to be of type rigid body 2D, and I'm going to call it my rbody, okay? Now this is going to hold my reference to a rigid body, okay? And when I say reference to a rigid body, it means my capability to change some of its properties, like change some of its settings and whatnot. And so what do? Well, I'm going to utilize this start function that's here and grab that component once right at the beginning of the game. And so here I'm going to say rbody is equal to get component rigid body 2D, and then that's it, okay? This little line of code here combined with this means that once at the beginning of my game, I am going to get access to that rigid body component, and I'm going to use that access periodically throughout my code. Okay, this now means that down here, I no longer have to get that access. I've already got it once up here at the beginning, so I can just reuse it over and over and over again. That means that I can take this variable rbody and reuse it down here in my code. So for instance, instead of saying get component rigid body dot velocity, we can now just say rbody. Okay, because it is the same rigid body I got earlier on. Same thing for in here, you can see we have get component position, get component position.y. Now we can replace all of these as well with rbody. Here's a nice little pro tip for Visual Studio. If you hold down the Alt key just beside your spacebar there, and then click and drag, you can actually click and drag and create columns across your text like this and fill it in using the same values there. Oops, I deleted something a bit much there. So what we need to do is get rid of the get component, rigid body dot position like that, and we replace it with rbody. Okay, and so that's making our code a little bit nicer to read. Okay, you can see here my position, clamping my position down should also be an rbody. Okay, and that's really everything that we have here. Okay. Now, so on our player controller, we've now updated it. So we've cached our reference to a rigid body there by declaring a private variable, grabbing that reference in our start function, and then basically overriding exactly what we had before, but now accessing it directly using the pre-reference cache that's there. I'm going to have a quick little peek here into random rotator because I do want to come back. You can see here again, this is in our start function. So calling get component is fine inside of the start function because we're not reusing it again later on in this code. But in our player controller, we are reusing it because we are using it over and over and over again in our update loop here. Now, speaking of update loops, I want to talk to you guys a little bit about how the update loop actually works. Okay, what I'm going to do here is I'm going to put a little bit of code here at the top of my update loop. I'm going to say debug.log, and I'm going to say here time.delta time. Okay, we've seen what time.delta time is. It is the amount of time in milliseconds that have elapsed since the previous time the update loop has been called. Okay, so I'm just going to save this here, and I'm going to go into Unity. Okay, I'm going to make sure my console is open, and I want you guys to see something. Here we go. Okay, so first off, I have this clamped value here that I want to get rid of. Okay, so let me just do that again here so we can look at this. Okay, we'll clear off the console and have a look at our console down here. Look at all of these different numbers. Okay, so if you look at them, they're almost close, but they're not equal. Okay, and if we look here and we bring up the calculator, what's 1 divided by 60? Okay, it's about 0.016. So you can see here this is around 0.016. Okay, obviously the units are a little bit off there, but it's hovering around that mark. It's not exact, but it's hovering around that mark. The actual number here doesn't matter. Okay, the actual values that you see here doesn't matter. What matters to me is the discrepancy in the values, is the fact that they are different, right? It's the fact that they're always different from one another. When we are working with physics, what we want is consistency, right? We love consistency when working with physics because we can predict things like collisions, we can have smoother movement, and all of that stuff. And so what we need to do here is we need to edit a little bit of our code from our update loop here because the update loop is inconsistent. Okay, the amount of time it takes to go to the next update loop is not consistent across every single frame. Luckily for us, Unity has a way of implementing this by modifying what our update loop actually does. We actually have multiple versions of our update loop, and if you're actually interested in understanding how Unity works with functions, so Unity function order, let me see here. I'm just bringing up an order of execution of functions in Unity. If you actually look at this, you can actually see various update functions occurring. So number one, you can see a fixed update, which is what we're going to be implementing here. We have our update loop towards the middle here. You have something called a late update loop that also can be used as well. All of these that you see here in white are functions that we can implement and utilize, okay? And so what we want to do here, you can see this update loop, okay, the update that's right there, comes after all of the physics has been already calculated. And so the discrepancy between calculating a bunch of physics and then my update loop being inconsistent can, in some cases, cause things like jitteriness, okay, and kind of weird, kind of like stuttering behaviors among the physics objects that are in the game. And so instead here, we want to do it in this fixed update, okay? And this fixed update is going to be consistent, all right? So just to demonstrate it, I'm going to change the name of update here to fixed update. You can see it turns blue because it is a keyword. If I now go back into Unity, turn this off and turn this on again, you are now going to see that this is constant, okay? It's not the same number. The precision of this is a little bit off, but it is the same number. It does not change. It does not waver at all, and that's very, very important for when we do physics calculations. What's neat about this, though, is we can combine and have an update and a fixed update loop. Okay, we can have both and just put our physics code inside a fixed update and our non-physics code in there. And so used for physics. I'll just put a little comment up at the top here and say used for physics. Okay, and so what we need to do is we need to go through here and figure out which part of our code is actually used for physics. And realistically, what's really used for physics here is this part up here, and this is the getting the input from our input manager here, manipulating velocity and clamping that position through the rigid body. Those are our physics operations because we are working with that rigid body component there. Here we are simply spawning an object based on a timer. So we're not worried about this being fixed based on time. We are worried about our physics. So I'm going to actually grab this whole top part here, I'm going to cut it, and I'm going to paste it inside of our fixed update. Okay, and that right there is a lot better because now this is going to ensure that this calculation will be consistent. The timing between each fixed upstate will be consistent. And this one here is doing non-physics work, which is good. We don't need to have that level of precision for non-physics work right there. Okay, so if we save it and we play it, we're going to notice absolutely zero difference, but it's still proper procedure. It's still important to make sure you get correctly. Okay. And that's pretty much it. So that's the first video that I wanted to cover with you guys, which was just simple code refactoring, okay, making our code a little bit nicer. We can even go back into this even further, but I think for now, the few things that we discussed in this video are a good way to get you guys started for you know, fixing up your codes in your own respective projects. Hopefully you guys can you know, build off of this. That's what I'm trying to say. Try to build off of this so that you guys can, you know, make some really, really cool levels in the future here. Okay, so the next video that we're going to be doing here, we're going to start working on spawning a whole bunch of asteroids all at once. Okay, we're going to look at that. So we'll see you there.